everyone. So welcome to this webinar on discovering the Environmental Design and Engineering MSc program. My name's Phil Simmons. I am the program director, and we also have Sarah Ardor, who is an alumni who graduated last year. She now works at HTA Design and was CIBSE runner-up undergraduate of the year last year. And we have Derya Arin, who is a current student. So the way this seminar is going to work is the first half an hour is a presentation from me, giving you sort of an overview of the program and some of the key things that you'll learn about. And then we'll open it up to a Q&A session where you can ask questions to both myself and Sarah Ardor and Derya. So I'll share my screen. So, as I said, I'm the program director, and the program itself, Environmental Design and Engineering, or EDE, as we like to call it, is one of the oldest in the UK at dealing with environmental issues associated with buildings, established over 40 years ago. So, as you can imagine, we've built up a lot of links internationally and in London and the wider UK area, with our alumni and with our connections to industry. And also as a growing institution, as part of the Institute of Environmental Design and Engineering, we're sort of a research powerhouse, and we're doing cutting edge research in the area of building decarbonisation, indoor air quality, and various other factors related to the built environment. In terms of the teaching ethos of environmental design and engineering, so we really try and foster critical thinking. So that means taking an analytical mindset and thinking about the why and the how, and making sure that everything is well thought through and really questioning the assumptions. We also like to use research to lead our teaching and help get the students involved in the research that's actually taking place on the ground. And that comes through in their dissertation projects as well. And then we do have strong industry and policy engagement within the department, and this is carried through into the programs. And we have design tutors from industry coming in to support students with their group projects. And the dissertation projects can involve some policy engagement as well. And in terms of the Institute for Environmental Design's mission statement, we're aiming to sort of inform decision makers to enable transformative change for cities and governments as we transition towards net zero and meet climate change targets. So the program also has a lot of networking opportunities, and it's not all hard work. There is some play as well. So we have things like during the induction week, we have a buildings walk where we go through central London, starting at UCL, ending up at the Gherkin building, where we look at the various architectural designs and some of London's most iconic buildings. And then in term one, we also have a trip to the Sustainability Centre in the South Downs National Park, where as well as some more academic activities, there is things like tree climbing and also some socials. Here is a list of the modules. I'm not going to go through each one by name, but this presentation is going to go through the key topics covered by all of the core modules. So in term one, there is 4 core modules, and these modules are aimed to help you understand the issues related to the built environment. But as well as that, it'll help upskill you and learn some new skills which can help tackle these issues. Followed by term two, where you're sort of developing solutions using the skills that you've learnt and the knowledge that you've acquired in term one. And then in term two and three, over the summer, you have the dissertation module, where you're involved in an active sort of research topic, which you'll choose in collaboration with a supervisor. And then you'll sort of have regular meetings to shape that research project. Uh, Term two, there's also a choice of optional modules, so you'll select two from some of these ones. There is also other optional modules which are hosted by other departments, and these can allow you to sort of specialize and also acquire sort of more multidisciplinary skills. So onto the modules themselves. So one of the first ones is energy and carbon in the context of sustainability. So this is sort of a big picture type module, which helps you understand the built environment as well as its context in the relationship to fossil fuels and decarbonisation. And why is this important? So I'm sure all of you are aware of the issue of rising temperatures. And this graph shows how temperatures have changed since 1850s. And globally, we're sort of approaching now 1.5 degrees C. And depending on what you use as the baseline, um, the 2024, if you use pre-industrial levels as the baseline, then we've also already sort of exceeded the 1.5 degree target in that single year. Um, and this is making the headlines all the time, and even just recently, the United States smashed its temperature record. I think it exceeded 44 degrees in Arizona last week. So it seems now like it's a regular occurrence that we're getting more and more extreme weather events, wildfires, flooding, and it's obviously something that is only going to get worse and needs to be tackled with urgency now. And it's well established that it's the carbon dioxide levels in the atmosphere which is leading to these increases in temperatures and the increase in extreme weather events. This plot on the left shows how it's called the hockey stick plot, which shows how the CO2 emissions have rapidly increased in the last centuries since fossil fuels have started being burned and pumped CO2 into the atmosphere. And this is just a zoomed in showing that it doesn't seem to be abating anytime soon. So it looks like unless urgent action is taken, those CO2 levels will continue to arise and will bake in more and more extreme weather. And in particular, the built environment is one of the key contributors to this factor, and it accounts for around 40% of energy-related carbon emissions, including both embodied and operational carbon. So it's obviously an area that needs tackling. So, as part of this module, the coursework is split into sort of two key components. The first part is investigating your own carbon emissions and critically analyzing them. And then the second component is through the skills of learning building simulation techniques. You'd use IES, which is one of the building performance simulation tools that we teach as part of the program. You'll use a model of a home and look at the impacts of retrofits on energy demand for that home. One of the other second module I'll go through is health, comfort, and well-being in the built environment. So obviously, as humans, we spend a lot of our time indoors, and we're exposed to a range of indoor air pollutants, ranging from cooking, possible garage emissions from the car, although if you've got an electric car, hopefully that could be negated. Uh, Chemical exposures from cleaning and paints, and basically all the materials you have in your house produce VOCs, so that's something we need to be aware of. Outdoor air pollution, although it has reduced in sort of some places over the last decades or more, it's still an important factor. So we need to think about how outdoor air pollution is coming indoors. And then, of course, there's things like dust, mites, bacteria, and things which could build up if in certain conditions in the indoor environment. And hopefully, most people by now have learned that smoking indoors is not the best idea for your indoor environmental quality. So we teach all of these aspects as part of that module, and also some of the health implications. So air pollution is responsible for a multitude of health impacts, which can affect basically every organ in the body, ranging from the brain, of course, the lungs. It can lead to lung cancer and COPD, um, irritation of the eyes, cardiovascular diseases, impacts on the digestive system and also the reproductive system. So obviously, trying to minimize our exposure to these harms of air pollution will have massive benefits in terms of health. Also, looking at indoor thermal conditions. So various studies have shown that there is an ideal sort of range for indoor temperatures and relative humidity, which is around 22 to 24 degrees, although it varies depending on your background and demographics and what you're used to. And then in terms of indoor relative humidity, there's this ideal zone around 40 to 60. Whereas if your relative humidity is too low, it can lead to viruses and respiratory issues. If relative humidity is too high, then you can get mold and moisture issues, as well as um, an ideal breeding ground for dust mites, which obviously you don't particularly want. In terms of what you'll do in that module, so this is one where I say we use sort of research-led teaching. So you're using cutting-edge wearable sensor that you'll each student basically carries this around for a few days, and you'll get to see what you're exposed to, and also you take a sleep diary and wear a smartwatch which tells you how your sleep has been, so you can investigate the impact of your various environmental exposures on sleep. Next on to the module I lead, which is called Built Environment Lab, Monitoring, Measurement and Analysis. So whilst other modules look at the what, so things like energy, ventilation, comfort and health, um, and other aspects, uh, and theory behind other aspects. This one looks more at the how in terms of your analytical skills. So it teaches you how to collect and analyze and present data, and how to use data to come up with some hypotheses and some solutions related to buildings, and then how you can then report those findings. We have a lab day which takes place at the Here East facilities in East London, where you'll undertake a series of 5 experiments on that lab day, on rotation. Each experiment is quite quick, it's around half an hour. So it's quite a fast-paced, fun day for the students. On top of that, there's a one-off day where students can develop their own experimental protocol using one of the cutting-edge thermal chambers at Here East. You see this one in the bottom right where you're able to sort of control temperatures, humidity, and other factors. And then as part of the coursework, as a group, you will be investigating one of UCL's lecture theatres. So you'll get assigned a lecture theatre, you'll undertake a physical survey, do some monitoring during a real lecture, and then do a questionnaire for the students who are in that lecture to see how they rate the UCL facilities, and we can use that and report that, and then we can also use that to feed back to UCL estates. The next term, well, the final term one module is called Computational Design for Sustainable Buildings. So as part of this, we are thinking about design considerations. So in terms of design considerations, there are some key things that we want out of our building. First and foremost, we want it to be functional and safe. We also want it to be energy efficient and as low operation carbon as possible and low embodied carbon. We want the indoor conditions to be good in terms of the temperature, light, and air quality due to the health implications I've mentioned. And also, of course, we want it to be aesthetically pleasing and low cost or within budget. And importantly, we want it to be regulation compliant. So some of these factors might be hard constraints. So things that we must comply with. So we must comply with regulations and we must fit within our budget. But various other factors, there may be certain trade-offs. So if you improve one thing, this might have a detrimental effect on one of the other aspects. So an example of a trade-off between daylighting and indoor overheating is shown here. So for example, if you change some of these design considerations like the orientation or the window to wall ratio, you might increase the solar gains coming in through the window, which is great for your daylight, but in the summer it might cause a problem in terms of overheating. So we need to sort of find the right balance in terms of our design considerations to make sure that we're getting the right um, balance, basically. And how do we do this? So there's a range of design tools. So as in this module, you'll be using Rhinoceros for the 3D geometry, and then a range of other plugins for Grasshopper to look at how you do parametric simulations and optimization to help you with those design trade-offs. And as part of the coursework, it's a real sort of case study design project looking at a UCL building. So this is 22 Gordon Street, and how you'd optimize the modular facade for this building. And this one is also guided by industry tutors. Onto the term two modules. So there's designing for the climate emergency. So I highlighted earlier, we need to be thinking about how to prepare best for the future. And there's a range of future scenarios in terms of warming, depending on how quickly we're able to cut the CO2 emissions. And this comes from the IPCC's assessment report, which was published in 2023. And it shows basically the range of uh, environmental outcomes depending on how quickly we can cut the emissions. So there's obviously a range of future temperatures ranging from basically current day or slightly worse than current day to extremely hot temperatures. So we need to think about how we design for those. And of course, there's mitigation where we want to reduce the causes of CO2, which are causing climate change, and lower the operational energy demand and embodied carbon, and decarbonize the energy supply from the grid as rapidly as possible. And that we also need to be considering how we adapt our buildings so that they can reduce the vulnerability to climate impacts. So preventing overheating, maintaining comfort under extreme weather, protecting occupant health, and ensure that they're sort of uh, remain usable in the future, and also are not going to get flooded, hopefully. And we are proponents of passive design. So passive design uses sort of the building itself and how it's configured to minimize the operational carbon. So we think about orientation and the what side and the great glazing fraction of the windows to maximize the solar gains during the winter. But we also have sort of seasonal shading so that in the height of summer, we're not getting direct solar radiation coming through those windows. Um, we want sort of ventilation, which ideally is naturally ventilated, so that it re doesn't require any sort of mechanical active system for the ventilation, and set this up so that we get a nice cool breeze during the summer. But we also want it to maintain air tightness in the winter, so that obviously it's not getting too cool. And we can have things like light colored roofs to help lower sort of the surrounding urban heat island temperatures. And there's various other design considerations like thermal mass, insulation, where we put our usable zones. So if we're spending most of our time in living room, then ideally that should be on the side which gets the daylight. As part of this module, it's quite exciting. You're involved in a real world design project, developing a fully passive house slash daycare. Past locations for this have included Lesotho in Southern Africa, Tanzania, and also Washington. For this project, your group is supported by industry design tutors, and it's also in collaboration with an NGO. So usually there's a sort of little competition where the best group then gets to present to the NGO at the end. So the final module I'll go through is called Net Zero Carbon Design and Engineering. As I've said, we're sort of proponents of passive design and passive first mentality, where the design of the building is key. But in quite a lot of climates, well, in most climates, actually, we need to also rely on active systems in order to provide heating and cooling, and in some cases, mechanical ventilation. If, for example, outdoor air pollution is particularly bad. So there is now emerging ways in which we can still achieve net zero even with active systems. So we want to be lean, we want to be clean, so using supply of energy efficiently, and also be green, so using renewable energy where possible, and then anything that we can't um, as completely remove in terms of CO2 emissions, then we should be offsetting that. And very recently, the net zero building standards was developed by the UK Green Building Council. And this sort of provides a step-by-step method for ensuring that the building can be net zero. So this starts at construction stage. So choosing the right materials with low embodied carbon, and then reducing operational energy use through some of the passive measures that I've mentioned, and then using renewables or a decarbonized grid to provide the energy to the building, and then offsetting any remaining carbon. So here's a sort of schematic of a net zero carbon home. Um, And basically, we're still applying all of the passive measures which were discussed earlier. Um, Now for the heating, we've got a heat pump, which is very efficient, much more efficient than using a boiler, and also uses electricity, so it should be cleaner. And there's also a mechanical system to provide air, but the overall f building facade is going to be very airtight. Um, in order to provide energy, we've got the solar panels and wind turbines, which um, hopefully through the summer at least should provide um, quite a lot of energy to the building. And then also there's a car here and a home charger. So we need to be thinking as well about batteries and how we can store the energy, so that we're storing up energy within a battery during the daytime and then using it when it's required later on. And this can help prevent too much demand on the grid as well. So here's an example of a net zero home, and it's developed by Max Fordman Architects, and it's in North London. So you can even walk past if you like. I think it's occupied though, so unfortunately we can't do a visit there. And as part of this module, again, you're using IES for the building simulation. In this case, you're considering an office environment, and you're comparing different HVAC systems and how they operate and trying to minimize the energy consumption and carbon associated with them, and comparing to the REBA 2030 target in order to try and achieve net zero, and trying to identify and evaluate measures to improve the performance of the system. And of course, we need to consider the embodied carbon of such heating and cooling systems as well, and consider the sort of whole life cycle of it. So that concludes my presentation. Thank you for listening. So I hope you've been encouraged to apply and join our global alumni. And we've got a long list of high achieving professionals who've got skills in the built environment and have gone on to do great things at Foster and Partners and Arup alongside many other industry giants in the area. We'll move on to the Q&A session. Here is my contact. So if you've got any questions related to the course, you don't want to ask them now, feel free to email me them. Or if they're more sort of administrative in nature, please use this email address if it's something to do with the admission process. So thank you. I will stop sharing my screen and we'll move to the Q&A session. So to start with, could I just get Sarah and Doya to quickly introduce themselves and tell them about your backgrounds and what you went on to do in EDE and why you chose EDE and what you're planning to do next, Doya, and what you're doing now, Sarah.
Okay, hi, I'm Sarah. I chose to study EDE because I came from an architecture background. I studied and worked for a bit as a part one architectural assistant, and I felt that I wanted to get more into sustainability and energy side of buildings. And honestly, I think studying this course was kind of the perfect holistic background that I could have asked for. It covers a really wide range of topics. You're not necessarily specializing in just one thing, although you can choose to explore your interests in your dissertation. I now work as a building physics and sustainability consultant at HTA Design. And in my job, honestly, I'm applying everything that I've learned in the course, which is really interesting. It's really good. Um, and I think I just really enjoyed the program for giving such a holistic view on all the issues to do with energy efficiency, building physics, renewable energies, and how also different disciplines come together, both within architecture, building services engineering, net zero engineering. all of them. And on that note, I think also actually the course is really well equipped for the transition from undergraduate to this master's. When I was studying, there was loads of different people from different backgrounds, whether it be architecture, engineering, geography, economics. And because of this, the course is really well equipped and structured to introduce everyone in a really well way. Um, yeah, that's kind of me for now.
Thanks, Sarah, and over to Duya. And yes, can I encourage everyone to put their questions in the chat window if you have them?
Hi guys, I'm Daria. I have a slightly different background than Sarah's. I was a mechanical engineer by training. I did my undergrad in the US and I worked as a mechanical engineer and a project manager, but not in the building space. So this course for me was more so a transition into a new industry and a new line of business. I've always been fairly interested in buildings, how they operate. I'm surrounded by architects, so it's always been something present in my life. But this course for me really brought together the technical and the artistic side of things, where just like Sarah said, we have a lot of different backgrounds, a lot of different architects, engineers, all sorts of people who are here. So it's nice to see that there's at least one class for each person where they're learning something completely new that they haven't done before. And it really helps to be in such a collaborative space and doing such different work from engineering to architecture to sustainability and bringing it all together in developing net zero living spaces and working spaces. So yeah, so that's kind of where I come from. It's fairly different than the standard architect background, but it's been a very rewarding course so far. And I am currently still in the course. This is actually the last week of classes for the second term. And I'm hoping to get a job in the engineering consultancy world, continue with the technical side of things, building physics, MEP engineer, those sort of things to work in that space.
Great, thanks, Duya. Could you both sort of describe what a typical week looks like for you? So, Sarah, now as what you're doing in your work, and then Duya, like within the program.
Sure, I'll start. So in my work, day to day really varies. It depends on what kind of project I am and what the work that we have to do is. It might be looking at energy efficiency in buildings. We might be doing SAP calculations to generate EPCs for a home, for example. We might also be working on early stage energy strategies for planning applications for buildings. Another task that I might be doing during the week might be an overheating assessment, which would be we use IES in practice, so something very applicable from the course to essentially assess a building's overheating risk. And then we would advise and inform the design team of here are the rooms that are failing, or here are the rooms that are passing. Here's what we advise for you to mitigate the overheating risks in these rooms. Another thing that we do is embodied carbon analysis and whole life carbon as well. And again, that's typically advising early stage designs on how to reduce their embodied carbon. Um, yeah, that's a few of the things that we do.
What scale of projects do you work with? Are they sort of big, large scale projects or sort of more small residential or?
The scale really varies. We specialize in residential and we across the different typologies. So it might be suburban housing, which might be, dwellings, terrace dwellings, or it might also be high-rise apartment blocks in city centres or again suburban centres. And that also really affects the strategies that are in play, whether it be overheating, energy, daylight, sunlight considerations as well. And I think it's really interesting how all these synergies interact with the different typologies.
Yeah, I guess you're looking at a lot of trade-offs.
Yeah, definitely.
And yeah, your typical EDE week, although I don't know if
Yeah,
there
it's
is.
it's actually quite funny before we get to the typical week. It's encouraging to hear that I've pretty much been doing the same things that you're doing in industry this past week because the course you explained, Phil, about the climate emergency and designing a passive house, um, I've pretty much spent last week doing IES simulations, analyzing overheating and underheating, how we can deal with those, running life cycle analysis, embodied carbon analysis. So it's encouraging to see that what we're doing in lectures and for our coursework is pretty much one-to-one translated into the professional world as well. But I'd say more of a standard week is probably 3 to 4 days. I try to be on campus. We have the lectures spread out, and there's quite a lot of work outside of lectures as well. I will say that as a full-time student, um, there's definitely quite a lot of projects and different coursework to work on, a lot of reading to do. But again, I think it all comes back to it's a very well-rounded look at the industry and what happens within it. So we get to experience a lot of the different aspects of it, and that obviously leads to quite a lot of work being done.
Thanks, Deya. And in terms of projects done as part of the program or the courseworks during the studies, have you had a sort of favorite project? You don't have to say my module.
Obviously, your module was the best, but I'll exclude it in the for the sake of fairness here. But one of the ones that I really enjoyed was in term one, for the uh, coursework we did for Daniel's class, where we were assigned the different types of housing, and then we got to analyze it and retrofit it, starting with the fabric, then going into the systems and moving on to even further retrofits like PVs. And that was really helpful to me because it was kind of the first time seeing everything we're learning come together. And also, it was where most of us learned the IES software for the first time. And that was really useful to have as a tool moving on, not only because obviously everyone uses it very heavily in industry, but even in, for example, the coursework for this term, we're using it a lot. And the more time you spend at it, the more proficient you are, the more you understand what you can do, what the limitations are, and most importantly, how to interpret the results so you can actually talk about them and analyze them and give proper feedback to your client. So I'd say that was a really good starting point for the coursework.
Thanks, Deya. And Sarah?
I think my favorite project was building solar design, although I feel like the module name might have changed now, but it was the project that Phil was talking about where you work with an NGO and you design a solar house essentially in a really different part of the world. That to me was a really interesting and fun group project because it essentially captured every kind of task, every aspect that we were talking about. We were looking at the energy efficiency of the building, we were looking at the embodied carbon of the building, and also the daylight access. So that to me was like the most well-rounded project, and you also got that little element of design in it, which was quite fun for me. Um, but yeah, that was my favorite, I think.
And do you want to say a bit about your dissertation? Because obviously that's one of the major undertakings in the
Mhm.
program. And there's a wide variety of topics people can choose from, and I haven't really had the chance to go into the wide range of things that can be done. But basically, any part of the program, you can specialize in that area and try and investigate a particular research gap. So perhaps Sarah, do you want to say a bit about what you did?
Yeah, sure. I'll just start off in the beginning a little bit. So there's a provided list of potential topics that is very long, and you can either pick one of the topics or propose your own. But even with the topic that you pick, it's you make it your own. You will find your own research gap and research question. And the process starts as early as January, February, I want to say. But the main bulk of the work begins in third term, kind of after April. And you have a supervisor. It's up to you to meet with them as often as you like. So my dissertation was looking at reducing overheating in epilepsy care homes, which was really quite interesting. It was a very niche topic to choose epilepsy care homes, but it was very prevalent issue as well. The buildings, especially in the UK and similar climates, our buildings are designed to retain heat and more for winter thermal efficiency, and which can often overlook summer heat hazards, which leads to overheating in buildings and risking residents' health essentially due to overheating and the health hazards that brings. Sorry. So I investigated hybrid cooling strategies, and I used IES to model a case study building, collaborating with the Epilepsy Society in Southeast England. And so I explored monitoring, modeling, and I also conducted a focus group. So it was a very mixed method approach, and that required a lot of planning with my supervisor and the case study care home that I was with. It was intense, but it was really interesting. It was really rewarding as well to be able to combine so many different methods of research. However, this was something that I chose to do. It's not something that you have to do. You could focus on monitoring, you could focus on just modeling, or, just more qualitative aspects, whether it be surveys and interviews. It also really depends on your topic, what you choose, and what the research gap is. There are a lot of other opportunities also to work with practices, if you so choose, and work on case study buildings. Or you could also work on a hypothetical building. You could also look more into research as a whole in terms of researching policies and regulations and seeing where things work, where they don't work. Yeah, I think it's essentially try to pick something that you're interested in. This will come to you in the first two terms as well. And yeah, run with it. See where you go, see what happens. I think that's all I can say.
Thanks, Sarah. Some good advice. Yeah, and some dissertations do get papers out of them, so journal papers. So that's great as well that some of the research that is done is novel and can be shared with the wider research community. Just got a couple more questions. So studying London, you've stayed in London, Sarah. So obviously you
Bill, if
like
you want, I can also weigh in on the dissertation. I know I haven't written mine yet, but it might be a good insight too, because I'm exactly at the point that Sarah was talking about of currently we've selected our dissertation topics. And as she said, the topics are pretty much what your supervisor would be interested in working in. So from there, it's really up to the individual to do the research and figure out what the research gap is in this field, how they want to address it, and then how they want to go about analyzing and studying this. So it can be very qualitative, very quantitative. I will probably approach mine. So I am looking at, there's a big debate these days around the accepted method for retrofitting most buildings for the longest time has been that you should start with the fabric first approach to make the building as low energy and as highly efficient as possible before moving on to any major systems changes. But over the last few years, this has been challenged, and there's a lot of debate around what methodology is most applicable for the widest batch of buildings. So I'll be looking into that, and I'm currently exactly at the state that Sarah was talking about of doing the research and trying to understand, okay, what do I feel like is missing in this field, and what can I spend my time on to try and address. And I don't know if Sarah's smiling because she has strong opinions about the Fabric First debate going on. I'm sure
It's just
I'm
very
sure
relevant.
yeah,
It's very relevant.
I'm sure people are talking about it in industry. So you can really figure out how you want to frame your topic and how you want to go about studying it. And I mean, as you can see, it can be very current issues that you're working on. So just wanted to weigh in on that.
Thanks, Dia. Sounds great. I look forward to hearing more about your topic in due course. Okay, so yeah, a couple more questions. So studying in London, obviously Sarah loves London because she's stayed on. So yeah, what would you say? And any advice?
Um, I think I stayed on because of the job that I got, but I do love London. I think it has so many opportunities for, in terms of everything like social life, creative, and also professional, especially. I think my biggest piece of advice I could give is not necessarily tailored to London, but on that note, is to join as many like committees and socials as you can. Um, that being said, the CIBSE group, the Chartered Institute of Building Services, they have a Young Engineers Network that I will say now already is join that group. They have a LinkedIn page, and I'm sure also UCL will promote them. But they have a lot of events, whether it be social or technical, and they're really great to not only learn things outside of your course that you might not typically learn, but also just to meet people and network. I've been going to them for the last year and I honestly really enjoy them. They're fun, they're informative, and everyone's really welcoming as well. So that's my advice that I would give.
Thanks, Sarah. Yeah, and as part of the program, so the program is accredited by CIBSE, so you're able to get free CIBSE membership for the year as well.
Make the
Do
most of
you?
it.
Yeah, make the most of it. Lots of good, great events. We also keep Wednesday afternoons free from teaching. So that's when basically all of UCL's clubs and sporting societies join up. So you can get involved in those as well. Do you?
Yeah, I'll support that as well. I'm a big fan of London. I've lived in quite a few places, but I do enjoy being in London. My advice would be a bit more social maybe than networking. As in UCL, also around London, there's a lot happening at all times. I mean, UCL itself, I don't know how many student groups there are. I went to the welcome things that they have. And pretty much any hobby you have, there will be a group of people doing it. And the same can be said for London. There's so many plays and shows and musicals and concerts, and it's such a lively city. It can be overwhelming, but I will say whatever you enjoy doing, I feel like you will be able to find a group of people who also enjoy it in London. So, great city and a great big university to be at to explore all these different things and try new things.